Welcome to The Explainer. Today, we're diving into something pretty wild. China is building what is essentially a single supercomputer the size of an entire country. And yeah, it could completely reshape the future of artificial intelligence. Okay, to really get your head around the scale of what we're talking about, let's kick things off with a little thought experiment. Imagine you've got this massive pile of data, 72 terabytes. That's thousands and thousands of HD movies. How would you move all of that from one city to another, hundreds of miles away?
Well, if you tried to do it over a standard internet connection, you'd be waiting for, get this, about 699 days. That's almost 2 years. But what if I told you this exact data transfer was just done in only 1.6 hours? The immediate question is, how is that even possible?
Well, the answer lies in this absolutely groundbreaking new piece of national infrastructure that was just switched on in China. And it represents a totally new way of thinking about computing power. It's called the Future Network Test Facility, or FNTF for short. Now, don't let the name fool you into thinking this is just some small research project. It's actually an incredibly powerful optical network that stretches for more than 1,200 miles. You see, the whole point of this, as the project's chief director put it, wasn't just to build a faster internet. The real goal was to fuse all these scattered computing facilities across the country, making them act as one single, unified, ultra-fast system. And, something like this doesn't just happen overnight. The FNTF is the result of a huge national project that's been in the works for more than a decade, a really key part of China's long-term science and tech strategy. So, how does this thing actually work? So, how in the world do you make data centers, separated by over 1,000 miles, act like they're sitting right next to each other? The secret isn't just about raw speed. It's about a revolutionary kind of network architecture. It's all thanks to something called a deterministic network. Let me break that down. On the regular internet, right, your data gets chopped up into packets and they can get stuck in digital traffic jams, get delayed, or even get lost entirely. A deterministic network, well, it completely changes the game. It's like having your own private high-speed highway for your data with guaranteed performance from start to finish. Okay, here's probably the best way to think about it. The FNTF works like a super precise, high-speed train system. Every single packet of data has its own reserved seat and a guaranteed arrival time. It completely eliminates all the chaos and unpredictability of the open internet. And this chart, it just shows you the difference in a really stark way. In a stress test, researchers hammered a standard internet channel with data, and you can see its speed just collapsed. It went to almost nothing. But the deterministic link, it took the exact same heavy load and didn't even break a sweat, maintaining its full 50 gigabits per second. Okay, so a super stable, ridiculously fast network is cool and all. But so what? What does this actually mean for something demanding like AI? Well, this is where things go from just impressive to honestly revolutionary. Take a look at this number, 16 seconds. That's how long it now takes to do one single training cycle or iteration for a massive AI model using this new network. And I know what you're thinking. Saving 20 seconds, who cares? But here's the thing. These giant AI models have to go through hundreds of thousands, sometimes millions of these iterations to learn. All those 20-second savings stack up, turning a job that might take months into just a fraction of the time. This kind of speed up just blows the doors open for some incredible applications. I mean, it's not just about cutting the time and money it takes to build new AI. Think about fields where every single millisecond is critical, like remote robotic surgery. And on a huge national scale, this thing is the backbone for massive strategic projects, like shifting data processing out to China's energy-rich western regions. But look, building a computer the size of a country, obviously that's not going to be easy. It comes with some massive challenges, and it really shifts the whole landscape of global tech competition. There are some really big hurdles here. First off, the sheer amount of energy needed to power all these linked data centers is going to be enormous. Second, just keeping a system this complex and spread out, stable and running is a huge technical feat. And maybe the biggest question of all is cybersecurity. How do you protect and control access to what is basically a strategic national asset? And for the rest of the world, this project is a huge wake-up call. The race to build the most powerful AI, it's not just about a few big tech companies anymore. It's escalating to a competition between entire nations and their state-funded super infrastructure.
So all of this really brings us to one final and, I think, crucial question about what this all means for the future of tech for all of us. Because China's FNTF isn't just a faster internet connection. It's more like a proof of concept for a whole new kind of computing, where the computer itself is the size of a country. And it really forces us to ask, what happens next? When the most powerful computing resources become integrated national assets, how will that change everything? Competition, collaboration, and discovery on a global scale? That is the profound question this giant computer leaves us with.